All right, so we're going to start some math on the bottom of page 42. So let's do a quick recap. We know that acids will contain hydrogens in the front, and when they break up in water, it will produce a hydrogen ion and an anion. And anions are negatively charged. Bases will contain a hydroxide, and if you put it in water, it will produce a hydroxide in the back and a cation. You always need to have a positive and negative charge. Now, if you know the concentration of protons, okay, your hydrogen ions, then you can calculate pH, okay? So these are the equations to calculate pH, okay? So here, if you have a high pH, okay, high pH means that you will have a very low concentration of hydrogens. So basically this is what it means. The more hydrogens that you have right here, the more hydrogens that you have, the concentration of hydrogen. So a little side note, when you see brackets like this means concentration, and you learned this word in your solutions unit. You're going to have a low pH. And a low pH means it's more acidic. So a pH that is like way down here means there's a lot of H's. There's a lot of H's in that solution, and therefore it is more acidic. Because the pH scale basically tells us the power of hydrogen. Basically, how much hydrogens are in our solution. So the more hydrogens you have, lower the pH, the more acidic it is, okay? Because remember, because acids have H's, right? The more H's you have, the more acidic you are. So if a pH is greater than 7, then we say that it's basic. It's on the base side. If the pH is equal to 7, then it is neutral. If the pH is less than 7, then it is acidic, okay? So let's try to calculate our pH, okay? Okay, so here are the two equations. They mean exactly the same thing. I should have already learned that this H and this hydronium mean the same thing, so don't be freaked out if you see one or the other. They mean the same. Okay, one more time, the reminder that the bracket means concentration, and concentration, another word for concentration is called molarity. Okay, all right, so here is a sample question. It says, what is the pH if the hydronium concentration is 5.2 times 10 to the negative 2? Okay, if it gives us this problem, then we need to follow this equation to find the pH. So you're going to do negative log of the concentration. Okay, so let's discover where these buttons are on our calculator. So the negative button is here. Negative button is here. Log button is right here. So you're going to press negative log, and you're going to type in 5.2. Remember to use the E button right here. So the second E button to the negative 2. So this is what it looks like on your calculator. You're going to put the negative, the log, 5.2 E negative 2. Remember, this times 2 gets replaced with E on your calculator. When you type that in, you should get 1.28. 1.28 is less than 7, so we know it is acidic. That means there are a lot of H's, okay? So I'm going to do one example here, one more example. So here is our hydrogen concentration. It wants to know pH because H's go with H's, okay? And then it's asking if it's acidic, basic, or neutral. Okay, so I have this concentration here, so that means I'm going to do, so you're going to go back and do negative log, so negative is here, log, and then you're going to type in 4.9 E. Remember, you're going to replace this with the letter E to the -7, and when you type that in, you should get 6.31. 6.31 is less than 7, so it is acidic. Okay, you try the next two, and you can pause here, and I'm just going to have the answers pop up. Okay, so the other two answers are now available. A question that some people have here is, oh, this one's not in scientific notation, but it's okay. It doesn't always have to be in scientific notation. Here it's a very, very low pH, 2.64, so we know that means we have a lot of H's, okay? All right, now, what if you want to go backwards, okay? If we want to go backwards, there's another equation here where we use anti-log, which is 10 to the negative pH. So here, we want to go from pH and go back to concentration. The way that we do that is we're going to use anti-log. So really quick on our calculator here, anti-log is basically second log. So you're going to press second, you're going to press log, and that is going to be anti-log. Okay, so second log is anti-log, so you're going to press second log, and then you're going to put negative of the pH. So what is the hydrogen concentration if the pH is 4.5? You're going to do anti-log, second log, and you're going to put that negative. Don't forget the negative. It really changes the answer, and you're going to put negative 4.5. When you do that, you're going to get this answer, 3.16 times 10 to the negative 5. And then it's a concentration, so you put capital M for molar, because concentration is molarity. Okay, so you try the next two. You're going to do your anti-log, so you're going from pH backwards to concentration, so you have 2.5. So you're going to do anti-log, which is second log, and you're going to press that negative, which is down here. Don't press subtract, but press negative. So second log, negative of your pH, which is 2.5 here, and you try to get the answer. So you can pause here and try the next two on your own, and then check your answers. They're going to pop up. Okay, remember that the pH will tell you if it's acidic or basic. So I forgot to mention earlier that 4.5 is less than 7, so it is acidic. And over down here, the 11.2 is larger than 7, so we put B because it's basic. That means there's not a lot of H's roaming around. Okay, that's what makes it basic. Okay, so here's a little practice chart down here. If you have pH, remember you are going to go this way by using anti-log. Anti-log is second log on your calculator, right? Which is second log, anti-log of negative pH. You can go this way to find pH by doing negative log, right? So try to fill out this chart on your own, and I'll put up the answers in just a second. All right, so here are the answers to the chart. If you have a question, then you can ask your teacher. But make sure you are using the correct equation to go to the correct spot. Okay, think about what you have and how can you get to the other side. I have this, I need to go to this side. Okay, so you're either doing negative log or you're doing anti-log. All right, let's go on to the next thing right here. We also can learn about pOH. So we already learned about pH. There's something called pOH, which tells us the power of hydroxide, which is the other side, right? So if you have a high hydroxide concentration, you're going to have a low pH, low pOH, because these are going to match, which means you have a high pH, therefore it is more basic. Basically, the more OHs you have, the more base it is. okay? Now, the equation to link pOH and pH is that if you add them together, you get 14. So, for example, if pH is 6, then what is the pOH? Well, 6 plus what will get us to 14? 6 plus 8 will get us to 14. Here's another example. If the pOH is 3 and you're going backwards to find pH, then what is the pH? So 3 plus what gets us to 14? It's 11. All right, you try the rest on your own, and then I'll have the answers pop up. All right, so those were the rest of the answers. Okay. Now, we can do the same type of equations, but instead of having H's, we just change it out with OH. So, for example here, the pOH, the power of hydroxide, is now the negative log of OH. So, earlier it was pH equals negative log of H, but now the OH matches the OH here. Okay, so now here's the example problem right here. It says, what is the pOH if the hydroxide concentration, remember it's in brackets, is equal to 3.7 times 10 to the negative 2? Okay, you're going to do the same thing that you did earlier, so you have to use the equation negative log of the hydroxide concentration. So you are going to do negative right here, and you're going to press log, and then you are going to do the concentration. So 3.7 times 10 to the negative 2. So then you're going to press the 3.72, okay? And then it has a little exponent here. Remember, this gets replaced with the letter E. So you're going to do E negative 2. How do you get to E? You do second, EE, and then do back to negative, and you're going to press 2 again. And then if you press enter, then you should get 1.43. Okay, let me do the next two examples. So here you have the concentration, you're trying to find pOH. So you're going to do negative log of this number right here. So you're going to type it into your calculator, negative log 0.002. If you type that in, then the pOH becomes 2.7. Now, how do I go from pOH to pH? Well, 2.7 plus this has to equal 14. So 14 minus 2.7 is going to get me 11.3. Now that you have the pH, you can answer this question. Is it acidic, basic, or neutral? Well, the pH is larger than 7, so it is basic. When it's basic, it means it has a lot of OHs and not a lot of H's. All right, so the next example, you can try on your own. You do negative log of this number. Type it in, 1. Remember, this has an exponent, so you're going to put the E on your calculator, negative 13, and hopefully you get the pOH to be 13. Now, if we want to go to pH, 13 plus what gets us to 14? 13 plus 1. So now that we have the pH, 1 is less than 7, so it is acidic. All right, we can go backwards just like we did earlier, okay? By using anti-log. Remember, anti-log is pressing second on your calculator, and then you're going to press the log button. Don't forget that negative sign, negative pOH. So it looks like this on your calculator. So here's the example. What is the hydroxide concentration if the pOH is equal to 2.5? So you have to press anti-log negative 2.5. So here, anti-log is second log, and then you're going to press the negative. The number is 2.5, so you're going to do 2.5. So go ahead and press that into your calculator, and hopefully you will get this number, which is 0.0032 molar. So you got to put some units on there. All right. So now let's try to go backwards this way by using anti-log to get to our concentration. So you're going to do anti-log, which is second log on your calculator, negative of 12.1, and you should get 7.94 times 10 to the negative 13. Okay, make sure you read to the end of your calculator, and then you're going to put an M for molar. Now, we still want to go this way because we want to know if it's acidic or basic. So 12.1 plus what will get us to 14? This is 14 minus 12.1 is 1.9. 1.9 is less than 7, so this is acidic. Okay, you can try the next two on your own. We're going to fill out the chart in just a jiffy. Okay, so hopefully you saw that you subtract to get to the pH, and then you can determine if it's acidic or basic. This 11.6 is greater than 7, so it is basic. So check your answers. Okay, so here is a practice chart that we're gonna work on together. And so let's just identify parts of this chart, okay? So there is a dividing line between your H's and OH. So here, the H's will always go with your H's. So this is the H side. And then the OH's will always go with OH's. So the right-hand side is your OH side. So if you notice that it is sort of divided down the middle. So there is a line down here. Okay, so I'm going to sort of divide this chart, and it sort of separates your H's from your OH's. So it looks like this. Okay, so there's green line separation here. Okay, so then let's think about your equations on the left-hand side and then the right-hand side. So here, okay, if you want the pH and you have the concentration, okay, so remember this is the concentration, then you're going to use negative log. So the equation is negative log of your hydrogen concentration will get you from here to here, okay? Now say you want to go backwards. Say you have pH and you want to go backwards to concentration. Then you have to use anti-log, which looks like 10 to the negative pH. So little note, this is anti-log, which is second log on your calculator. The same thing, okay, looks the same on the other side. If you have concentration and you want to know pOH, you're going to use negative log of the hydroxide concentration. So you can go from here to here. Now, if you want to go backwards, if you have pOH and you want to know the hydroxide concentration, then you're going to be using your anti-log, which looks like 10 to the negative pOH. Remember, this is anti-log, which is second log on your calculator. Now, how can we go from the left hand to the right hand side? What connects our H's with our OH? It's that last equation that we learned, right? So you have P of your H, so these are your H's, okay, and you can add P of your OH's, and what do they equal to? They will equal to 14. So that's what connects this with this side right here, okay? So these two are connected by pH, and pOH equals 14. Now, a little reminder as well that if you want to answer this right here, you always need to look at this right here. The pH is either going to be less than 7, equal to 7, or more than 7. So here's, I'm going to do just a couple of examples, and then I'm going to fill out the rest of the chart. Okay, so you have pH 3.87. Now you can go backwards here. So you can go this way by using antilog. So you're going to follow the line. You're going to use antilog. So you're going to do second log of negative 3.78. So don't ever forget that negative. And hopefully you got 1.66 times 10 to the negative 4. And you're going to put M for molar. Okay? So I'm going to make my M a little bit clearer there. Okay, so now the question is, how can I connect to the other side? I want to cross this bridge over here. If you want to do that, then you are going to use this equation down here, which is pH plus pOH equals 14. So if I subtract 14 minus 3.78, so 3.78 from 14, then right here, this becomes, my pOH is 10.22, because 10.22 and 3.78 equals 14. Now, how can I go from pOH to hydroxide concentration? Well, if I follow my map, I'm going to use my antilog once again. So I'm going to do antilog of negative 10.22, which is second log on your calculator. So go ahead and type it with me, and you should get 6.03 times 10 to the negative 11 molar. Okay, once you get that, okay, now we can answer this last question right here. Now remember, to answer this question, I need to look at pH over here. The pH is 3.78, which is less than 7, so I'm going to put A for acidic. Now, you can do the rest of this chart. Actually, I'll do one more example, number 2, to help you, and then I will put the answers to the rest of this chart. Okay, so now you have this concentration, so you want to go backwards over here. If you want to find out the pOH, according to your little map here, I have to do negative log of my hydroxide concentration. So you're going to type negative log on your calculator. You're going to do 4.5. Remember, this gets replaced by the letter E on your calculator. So 4.5 E to the negative 4, and you should get 3.35 on your as your answer. Okay, so now we want to cross this, and we want to go to this side to find pH. You know that pH and pOH are linked by 14. So if you do 14 minus 3.35, then you can find the pH, which is 10.65. Okay, if you want to go backwards this way, okay, according to your map up at the top, if you want to go from pH to hydrogen concentration, you have to do the antilog. The antilog is second log of negative 10.65, and it becomes 2.24 times 10 to the negative 11, and you got to put that M for molar, okay? All right, you try the rest of the chart on your own, and I'm just going to type in the rest of the numbers, and it's going to magically appear. So make sure you know how to use all 5 equations. Just really quick, I forgot to do this last question. 10.65 is greater than 7, so this makes it a basic solution. All right, now try the rest of the problems on your own. All right, so hopefully you got the rest of this chart. If you have any questions, then go ask your teacher.